All right, let's look at a maximizing revenue problem. It says a business sells 2,000 units of its product per month at a price of $10 each. It could sell 250 more items per month for each 25 cents reduction in price. What price per unit will maximize the monthly revenue? So what are we given here? We're given two different price points. So if I have this unit, I could sell it for this much, and then it gives us a change in that. So what are we going to have to do here? Well, the big picture is that we want to maximize our revenue. And to maximize our revenue, we have to remember that revenue is X times P, where P is the price-demand equation. So the first thing we want to do is find our price-demand equation. That's the first thing we need to do, is find price-demand equation. Well, our price-demand equation is a linear function related to the quantity that we sell it for and the price that we sell it for. So what we need to do now is realize that for our price demand, we have ordered pairs X, comma, P, where X is the quantity and P is the price. So if we read this problem, we can look at the first one where it says 2,000 units of sold at a price of $10 each. That gives us the ordered pair of 2,000, comma, 10. Again, X being the number of units sold, Y being the price that we sold it for. Reading the second sentence, it says it could sell 250 more items if it reduces the price 25 cents. So the second point that we have would be 250 more items, which would be 2,250 items. That would be if it sold it for a total of $9.75, a 25% reduction in the price. So here's two different points, and we know if we have two different points, we can find the equation of a line. To find the equation of the line, we first find the slope. Slope is the change in y, 9.75 minus 10, all over the change in x, 2250 minus 2,000. Go ahead and put that into your calculator now, and let's find out the slope of the price-demand line. I'm getting a slope of negative 0.001. That's the slope of my price-demand model. Now I need to find the equation of it. Again, I'm going to use the point-slope formula, so y minus y1 equals m times x minus x1. I could use either of the points. I'll use the point 2010. So I'll have y minus 10 is going to equal that slope, which was negative 0.001, times x minus the x value was 2,000. I'll go ahead and do out some math here. So I have y minus 10 equals negative 0.001x minus 2, plus 2, because you have a negative times a negative is a positive. Then we're going to go ahead and add 10 to both sides of this. When I add 10 to both sides of this, I'm ending up with y, which is my p-value here, is equal to negative 0.001x plus 12. So that's my price demand function right here, my price demand function. Again, the way that I found my price demand function is by creating 2 points with the x value being the quantity, the y value being the price. I was able to find the price demand function. That is not what I'm trying to maximize, though. What I'm trying to maximize is revenue. So I need to go back up into my revenue function, which is x times p, using the price demand that I just got. So it seems we would have the revenue function would be x times this new price demand, which was negative 0.001x plus 12. Or I could say my revenue function is negative 0.001x squared plus 12x. Now that I finally have my revenue function, now I can look at maximizing my revenue. Once again, we could use the first order derivative test, but the first thing is we need to find its derivative and then its critical values. So this would be negative 0.002x plus 12. I'm going to go ahead and set that equal to 0. Subtract 12 from both sides. I'd have negative 0.002x equals negative 12. Divide both sides by negative 0.002. When I do that, I'm ending up with x equals, put that into your calculator, I'm getting 6,000. So this is my critical value. Notice the derivative's never equal to 0. It's linear, so it's never equal to 0. never undefined, so I don't need to worry about where it's undefined. So I just worry about this critical value. I need to prove that this is a maximum. The way that I prove that it's a maximum is the first or second derivative test. Second derivative is really easy to find here, so I'll find the second derivative, which would be negative 0.002. Derivative of x is 1, derivative of 12 is 0. So that tells me my second derivative is always, regardless of the x value, negative. My second derivative negative tells me that my function has to be concave down. Because that point is a critical value and it's concave down, that tells me when x equals 6,000, we have a maximum, which is exactly what we wanted. So that's not necessarily the answer to the question. Let's go back and read. It says, what price will maximize the revenue? What we determined was what quantity. X is the quantity that'll maximize revenue. So what do I need to do? I need to plug that back in to the price function. Well, we know what the price function is, so this isn't too bad. It's just one more step of work here. So to find the price, what we're going to do is negative 0.001. Our X value that we figured was 6,000. And then we have plus 12. Please plug that into your calculator now. And let's see what you get. I'm getting a price of 6. Read back the question, make sure what that stands for. What that stands for is dollars per unit. So at a price point of $6 per unit, that's what the company should charge. That will maximize their revenue. $6 per unit. Okay, let's move on to the last example here, example 4. Example 4 says let's maximize profit. Remember, profit is revenue minus cost, and revenue is quantity times price, or X times P. So those are just some things to keep in mind. It says find the price that will maximize profit for the demand and cost functions P equals 4 over root X and C equals 2X plus 50, where P is the price per unit in dollars and X is the number of units and C is the cost in dollars. So if we want to maximize profit, we need to find profit. Remember that your profit function is always your revenue function minus your cost function. So the first thing we need to do is we know the cost function, we need to find the revenue function. So remember your revenue function is X times P. Well, we're given P, so that's not too bad here. So our R is going to be X times 4 over the square root of X. If you simplify that, X divided by the square root of X is the square root of X. So here I have that my revenue function is 4 times the square root of X is the simplified version. Now that I know my revenue function and I know my cost function, I can find my profit function. So my profit function here would be my revenue, which was 4 square root of X, minus my cost. I'm always going to put this in parentheses. Please be very, very careful with that. Put it in parentheses because here you'll see we need to distribute the negative. So I'm ending up with my profit function, not my price demand function. My profit function is 4 root X minus 2X minus 50. So now that I have now that I have my profit function, what can I do with that? I want to maximize that. How do I maximize my profit? Find the first derivative, find the critical values, use the first derivative test or second derivative test. So let's find the derivative of this. The derivative of 4 square root of X, that's 4x to the 1/2, would be 4 times 1/2 x to the negative 1/2. The derivative of negative 2x is negative 2, and the derivative of negative 50 is 0. Cleaning this up, well, we have the 4 divided by 2. This would be a 2. I'm going to throw the x to the negative 1/2 in the denominator. So I'm ending up with, what would that be? 2 over the square root of x minus 2. If I want to get a common denominator, I multiply that second term by square root of x over square root of x. Combining like terms, I'm ending up with my derivative would be, 2 minus 2 root x all over the square root of x. Okay. So now I need to consider when is this derivative. I need to find the critical values. So when is this derivative equal to 0? And when is this derivative undefined? Well, it's undefined when the denominator equals 0. Squaring both sides, that would give me x equals 0, which means don't produce anything. That's not an option. It would be equal to 0 when the numerator's equal to 0. So I'm going to solve that. I have 2 equals 2 square root of x. I divide both sides by 2. I have 1 equals the square root of x, square both sides, and you get x equals 1. So there's my critical value right there. The only critical value I need to consider is x equals 1. How am I going to test to make sure that this is a maximum? I could go ahead and do the second derivative test. But I do want to show you which one I'm going to use. I'm going to use this version of the derivative. That's p prime equals, how about 2x to the negative 1/2 minus 2. That's the version that I'm going to use for the second derivative test. So when I find the second derivative of this, it's going to be 2 times negative 1/2 x to the negative 3/2. Derivative of negative 2 is 0. Simplifying my 2's, figure out what I have here. This would be a negative 1 over, well, that would be the square root of x cubed. What number am I plugging in? I'm plugging in the number 1, my critical value. So my second derivative would be negative 1 over the square root of 1 cubed, which would be a negative number. Because my second derivative is negative, that tells me that my original profit function would have to be concave down. Because that function is concave down, that tells me at x equals 1, I have a maximum. Again, that's exactly what I wanted to know. I wanted to know what would maximize my profit, but I need to be really careful here. I got x equals 1. Let's think about what x stood for. X here is the quantity or the number of units, but it says find the price. The actual problem wanted the price that will maximize profit, not the number of units. So it wants the price that we have to charge. So I'm going to have to go back to the price function, which was given to us in the original problem. And to find the price, I do that the lowercase p is going to be 4 over the square root of 1, which is 4. So it seems to me, if we reread it, it's the price is in dollars, x is the number of units. So what price should I charge? I should charge $4 per unit. And if I charge $4 per unit, I will have maximized my profit.